Hello everyone, in this video let's discuss about inverting amplifier circuit. So if you are new to our channel, please subscribe for more engineering related topics. So in amplifier circuits we will discuss about inverting and non-inverting circuits. So let's discuss about what is inverting and non-inverting terminal. So operational amplifiers we will be using instead of amplifier. So the operational amplifier will be having negative terminal and positive terminal, that is two inputs and single output. So this negative terminal will be called as inverting terminal. Negative terminal will be called as inverting terminal, and this positive terminal is called as non-inverting terminal. Non-inverting terminal. So let us consider a waveform, that is a voltage waveform that is having both positive and negative half cycle. If you give to the negative, that is inverting terminal of the operational amplifier as an input, so the output will be inverted, that is 180-degree phase shift with amplification. That is their height will be increased. Height means amplitude will be increased, but in the opposite direction. This is positive, no? So positive, negative. So there will be 180-degree phase shift. 180-degree phase shift in inverting terminal. But if you give the same input to the non-inverting terminal, that is positive terminal, it will just amplify the wave. That is, it will increase the height of the wave. Positive and negative of cycle will be same. It don't inverts. There will be no phase shift. There will be only increase in the amplitude. Hope you understood. Now we are designing the inverting amplifier circuit. So the input must be given to the negative terminal. So let's consider the input voltage as V in and the resistance as R1. And this is called as the feedback circuit. It will be connected to negative terminal and the output voltage V out or V0. So the resistance across this is called as feedback resistance RF. Next, this is the negative terminal and this is positive terminal. Voltage across negative terminal, let's call it as VA, and voltage across positive terminal, let's call it as VB. So we also know that voltage across the positive terminal and voltage across the negative terminal will be equal. So VA is equal to VB. Since VB is connected to ground, VB value will be equal to 0. Therefore, as VB value will be equal to 0, VA value will also be equal to 0. As VB value equal to 0, VA value will also be equal to 0. Now we must form an equation so that the output voltage must be inverted value of the input voltage. Output voltage must be inverted value of input voltage. So let's consider two equations. That is the input equation from V in up to VA, that is up to negative terminal. Then another is feedback, that is output side equation from VA towards V out. So now at input end, when there is voltage and resistance, the current will flow. So therefore the current will start flowing right here, and there is no another circuits like capacitor or anything. It will flow in the same direction. So it will flow to output. So in input side and in output side, both the sides the current is common current is flowing. So let's form the equation in form of current. So we know that through Ohm's law we know that V is equal to IR. We need the formula of I, that is current. So current I is equal to V divided by R. Now let's use this equation and form the input side equation. That is, what is the voltage? V in and VA, both are there. So the current is flowing from V in towards VA. So I is equal to V in minus VA divided by, what is the resistance in the input side? That is between V in and VA, R1. Next, I is equal to, we know the value of VA. what is the value of VA? VA is equal to VB, but VB is grounded, so its value is equal to 0. Therefore, VA value will also be equal to 0. So, V in divided by R1 will be left, as VA value will be equal to 0. Let's call this equation number 1. At the output end, so output end means it will include the feedback circuit, that is from VA, that is negative terminal voltage, to output voltage V0. So the same current is flowing. I is equal to VA minus V out, that is V0. From VA it is going to V out. So divided by, what is the resistance in between VA and VO? That is RF, that is feedback resistance RF. We know the value of VA. VA is equal to 0. So let's substitute. So 0 minus V0 divided by RF. What will be the value? I is equal to output voltage divided by feedback resistance minus. So let's call this equation number 2. Since the left hand side of both the equation, that is current is common in both the equation, let's equate equation number 1 is equal to equation number 2, because left hand sides are equal. So right hand side, what is there in equation 1? V in divided by R1, which is equal to minus V out divided by RF. We need the equation of V out, so we will send the minus and RF to left hand side. When we send the RF, that is feedback resistance, which is in denominator, it will go to numerator. Therefore minus RF by R1 into V in, which is equal to output voltage V out. So what is negative symbol representing? It is representing that the input is given to the negative terminal of the operational amplifier. So what is that? The inversion of the input voltage will be the output voltage. Next, therefore, what will be the voltage gain? That is AV. Voltage gain is equal to output voltage divided by input voltage. So output voltage is there. If I send input voltage to this side, it will go to denominator. Therefore, what will be left? Minus RF divided by R1. So this is the voltage gain of the inverting amplifier circuit. Hope you understood the video. If you like the video, please subscribe. Thank you.